Your next challenge in the 7 Caillou series is called Is This a Triangle? You are to implement a function that accepts 3 integer values labeled a, b, and c. The function should return true if a triangle can be built with the sides of given length and false in any other case. In this case, all triangles must have a surface greater than 0 to be accepted. So that's sort of your note that you don't have to do any error checking. In a real life situation, we'd probably verify that a, b, and c, each of those are all greater than 0. And you can certainly do that here if you just want to adhere to good practices. But you know what to do. Pause it, have a go, and come on back when you're ready. So this is kind of more of a math problem than coding at this point. You know, if you could think of the way to know if 3 sides make a triangle, and it comes down to basically checking each combination and assuring that for each pair of sides, any 2 that you match, they're greater in length than the third side rather. And to visually imagine that, I mean, you can think, right? You would never have 2 sides in a straight line, right? They're always they come to a point, right? They form an angle. But in the most extreme case, the biggest angle, almost 180 degrees, right? If 2 of those sides don't even measure up to the third side, I mean, the lines aren't even the same length. There's no way that the triangle can reach the end of the third side. Hopefully that makes sense for envisioning why this approach works. And you can Google that too if you ever get stuck or want to see some explanation for that. So then let's return a Boolean, right? They're looking for a Boolean, true or false. And we're going to put a bunch of conditions. We're going to do each pairing. We can say A and B. Notice we're using the double ampersand here. That's a logical and. So, I'm sorry, I'm getting ahead of myself. A plus B is greater than C. That's our first combination. Then we do our double ampersand and. Remember, we want to check all 3 combinations. A plus C is greater than B, and B plus C is greater than A, and that covers all 3. And if this is the case, then we have a valid triangle. Otherwise, they don't make a triangle. And we can return that. And it looks good. So, I mean, you may have done it. You could write it out with if statements too. It's just a little more verbose than it needs to be. You could have just put this whole thing in an if, right? And if that were true, you could say return true. Else, remember, we don't need the else because we already return if we meet this condition. Otherwise false. You could have done it this way too, right? But to me, that's a little more typing than is necessary. This one is just as clear in my opinion, but your mileage may vary. So yeah, not much else to say about this. These are the logical operators. There's a single version as well if you want to look up the logical operators for doing bitwise comparisons. But when we're checking expressions like this, each one of these is an expression, right? It's performing an addition and checking whether or not it's greater than another value. So think of that question in itself. If I ask you if one number is greater than the other, it's either true or false, right? So each one of these expressions evaluates to a true or false. And for this thing to return successfully, all 3 of these have to return true. If any one of them is false, the whole thing will return false. And if you want to look up Boolean logic and how that works, that may be helpful if you're not so comfortable with that. But this is contrasted with the idea of an OR operation, which is that vertical bar, these two ORs. If any one of an OR is true, then the whole expression is true. And the logic is usually smart enough to short circuit, they say, where if the first one evaluates true, they don't even bother checking the other ones because they know that the overall expression is true no matter if you had 100 falses after this. If one of them's true and you're using all ORs, then the whole expression is true. And kind of the same thing with, but the opposite with ands, right? If this first one were false, you wouldn't even need to check the other two. You could have 100 trues and one false, but since we have this hard requirement that says and this, and that, and this, you have to meet all of the criteria to sort of meet the overall condition. So yeah, you can ask me questions as normal if you'd like. Otherwise, you can look into Boolean logic. Let's go ahead and make sure this whole thing works before we call it. Looks good. I'll go ahead and submit. Let's check out quick what other people did. And so they kind of added, you can see they basically did the same thing, but they, good, you do the checks that it's greater than 0. The problem told us we didn't have to worry about it, so I was pretty relaxed there. Looks like the same thing down here. Okay, they call that the triangle inequality theorem. I don't remember back to those days, but it sounds good. Sounds right. You can search that term. Links. Okay, so they made a collection and sorted, so I guess they only needed to check one expression once they were sorted. Okay. You've got some extra work of creating a list. I don't know if I'd say it's better in this case of only 3 sides, but okay. Same idea, kind of. System mathematics. Yeah, so some people tried to find the biggest side so they could just do one check. I don't know, I kind of like what we did. And there's that more verbose version. So yeah, not much else to see there. I will call it, we collected our points, and we'll move on to another challenge. Thanks for watching.